So let me walk you through the dashboard. Okay. So the first area I want to talk about is called, I told like by default, there will be 4 namespaces that will be created, right? Even in the command prompt, if I go kubectl get namespace. So these are all the 4 default namespace that will be created. And in the cluster, the Kubernetes dashboard is pre-installed. Okay. So there is one more namespace called dashboard is created, and the dashboard is getting deployed there. Okay. So if you remember in the previous method, when we do it, the dashboard was not available because in this cluster configuration, I have manually installed the dashboard. During the bringing up the cluster, it will automatically install the Kubernetes dashboard and give it to you. So Kubernetes dashboard is not a default implementation in the cluster. You have to do it extra. So to get more information about the dashboard, there is a GitHub repository for that. You can get information about that. Kubernetes, the GitHub repo for it. I'll just share you. So this is the actual source code of the dashboard. Okay. And they will have the proper instructions how to set up and all those things. You can just refer it whenever it is needed. Fine. So in the dashboard, in the top, you are allowed to choose a specific namespace. And in the front page, it is going to talk about what are all the components running on the particular namespace. Okay, let's talk about the kube system, right? In the kube system, there are some daemon sets running, deployments running, pods running, and replica sets running. Okay, so I told you, whenever you are creating application in Kubernetes, the first thing you will be creating is called the deployment. Okay, and the deployment will be creating the replica set, and the replica set will be creating the actual pods. Pods are nothing but your running containers. So that is what we are seeing here. I will talk about the daemon set shortly. Okay, so the first important thing we want to talk about is called as a deployment. A deployment will be creating a replica set, and replica set will be creating the pods. Okay, we'll start talking about the deployment. So deployment is something, this is where you are going to tell what should be the, let me just take an example of Kubernetes dashboard itself. So this is my Kubernetes dashboard. Okay, I will see what is the name of the deployment, under which namespace I want this to be deployed, when it is created. Okay, and what all the labels are used for it. Okay, I told labels are very, very important in the Kubernetes, right? So you can see the labels there. Okay, and what should be the deployment strategy? Okay, I told various deployment strategies yesterday, right? Rolling update. The default deployment strategy followed by Kubernetes is called rolling update. Okay, in the rolling update also, I can talk about what should be the rolling update strategy. Like for example, in a deployment, I have 4 pods to be brought up. Like let's say, let's take the PowerPoint. Let's say on a deployment, I want 4 pods to be running, right? Okay, so here in the deployment strategy, I'm talking about max surge and max unavailable. That means when I'm doing this deployment, let's say I'll be taking this pod 1 out. Okay, see, because 25% is like out of 4, 1 will be there. Okay, so I can take maximum of 1 container out. Okay, by the time 3 containers will be living, and this pod will be having this pod will be having the new code. So let me just fill in the color. So this will be having the new code. Okay, now while doing these changes, like this will be taken out. Okay, let's say pod 2 will be taken out. Okay, so pod 2 will be taken up, new code will be put. Okay, So while just keep on repeating that, I may have a scenario that it can go maximum of 5 containers. Okay. So basically what it does is, sorry. So the new pod 2 will be brought up, then only the new pod 2 will be brought up, then only the actual pod 2 will be removed. So that it can spike up to 25%. Like if I have a 4 pod deployment, it can go up to 5 pods when it is exchanging that, right? Putting the new pod and other stuff. That is what I'm defining in the 25%. So 25% means in the 4 pod scenario, it can take 1 container out of the equation, okay? And it can go up to 5 containers on the same time, okay? If I change it to 50-50, let's say if I'm saying the max surge is, max unavailable is 50, it will take 2 containers out, okay? And it will deploy the new code, and then it will attach it to the load balancer, and then it will remove the old, old containers with the max surge scenario, okay? So this is what the rolling update strategy. This is the default thing, okay? And you can see about it is going to call a replica set. I told it will be calling a deployment will call a replica set. We'll go to the replica set and see it. Okay. And using this replica set only, the deployment histories will be managed. So for every deployment, a new replica set will be generated. Okay. So by keeping the replica set information in the history, okay, you are going to keep the allow you to roll back to the previous version. We will see that in detail in the lab. Okay, so just so the deployment history will be stored in the name of replica set. So if you see that revision history limit for a for this deployment is 10. So it will keep 10 deployments in the history. So you are allowed to go back till last 10 deployments. If you want to roll back to the like previous 5th version, you can go to that 5th version also. We'll see a detailed lab about how to roll back to a particular version of the deployment. Okay, these are all the information you can see that. Okay, and here you are allowed to scale the replicas also. Like for example, currently in the deployment, I have 4 pods running. I want to increase it to 8 in a manual method. It's not an automated method. If I want to do that, I can do that using the scale option, or otherwise in the command line also I can do it. We'll see that later. And in the dashboard, I'm allowed to edit the deployment also. So if you see that deployment, it can give you the YAML or JSON format of the deployment. Let me show the YAML. So whatever YAML we are writing, right, the same you can see it here. There, imagine I want to change the image name of it. So I can just find it. So this is the volume. It is attaching a volume. And this is the image name. Imagine I want to change the image of it. I'm allowed to change it in the UI also. Even if you make changes here, it will deploy that. We'll see that example, how to modify a deployment and what should be the port number it should be exposed to. So all those things you can change it. Okay, we'll talk about that later, how to edit a deployment. Okay, and if I want to delete a deployment, I can delete it. This will delete the deployment. We'll play around with all these areas. So these are all the information you will see in a deployment, and you can see, is there any old replica set? That means if I do one more deployment, I can see the old replica sets. And then next is the horizontal pod autoscaler. This is where you are defining the auto scaling options. We can see that. And events is what happened on the deployment. You can see the events here. These are all the information you will see in the deployment. And I told you the deployment will creating a replica set, right? So the replica set name is 78C. So if I go to the replica set, I can see one replica set, which basically this will call the pod. You can see the pod informations here. So this is the pod which is running. You can see that in the pod. So these are the pod. This is the Kubernetes dashboard pod which is running. So there you can see about things like when it is brought up. Okay, if I have any volume attached, I can see it here. And what is the container? Okay, what is the image I'm using it? And if I have any mount points defined, what are all the mount points? Okay. And what is the user it is running, right? Whether it is read-only file system, all those information I can get about the pod. Okay. This is on the pod. Replica set and then pod. And the next thing, deployment, we have talked about. Next concept is called jobs. Jobs are something like you want to run a one-time activity, you can define them as a job. Cron jobs are scheduled jobs. Jobs are like just a container, you're running it for one time. So you can have a scenario when you're bringing up application, you have some specific steps need to be performed on the container. So then you can define them as the jobs. Okay, this is on the jobs. Pods we have talked about. Replica sets also we have talked about. And replication controller is a older version of replica set. So basically, previously we were using replication controller. There we will not be able to define an affinity. Okay, so the pod affinity is one concept. Okay, if you remember in the Docker we told that you cannot run a Windows container directly on a Linux machine, right? So in that case, in the Kubernetes cluster, you can add a Windows node as a client. Then you can say that this is a Windows container, so I want it to run on the Windows node. So those kind of node affinity or other things were not possible in the replication controller. That's where the replica set comes in, where we can define a node affinity so that this container will run only on that particular node or node group. We can also create a node group so that the container will run only on that particular node group. Okay, these are all the concepts for the advantage of replica sets over replication controller. Okay, and next concept is called stateful set. So stateful set is something like within the container you want to maintain the state. A typical example will be, imagine you have a database scenario. In a database you can have only one write master. Okay, others can be a read master. In that case, if you want to define them in active passive method, then you will be using a stateful set. Whenever you want to exchange the state between the containers, then you can define them as a stateful set. This is the example of a stateful set. Okay, these are all the various container related resources available in the Kubernetes. Okay, and you see a n in the thing, right? So that means these components are namespace specific. So some of the resources are namespace specific, some resources are not. So whatever we are discussed now are namespace specific. So when you create a cron job, you have to provide a namespace, otherwise it will get created in the default namespace. Okay, so like that, services also namespaces. Okay, in services there are two kinds of services available. One is the load balancer and another one is the ingress. So node port doesn't comes in here. So whenever you want to see an external service, if you define this as a load balancer, you will see that here. Yeah. Any question? So in the dashboard, we have services. Okay, that is also namespace specific. So services is something like, this is where I'm going to talk about whether I'm going to expose the container, the pod as an external service or an internal service. I'll be able to see that. Or if I configure an ingress controller, I can see them. So in this case, in my kube system, let me just take the dashboard here. In the dashboard, I can see these are the Kubernetes is not exposed as a external service. It is exposed as an internal service. Okay. But if I see the kube system, there is no external service. Not a problem. Okay. And I don't have an ingress controller configured, so it is empty now.